Alright, so we're quickly going to be going through atomic theory applied. So we've already talked about the basics of atomic theory. We know about protons and electrons and how they were discovered, talked about neutrons. Now, points, table, obviously you need to copy the table into your notes. Pick up on a couple of things. The electron's mass is basically meaningless. On the symbols here for neutron, actually what we're going to be using for a neutron is we're going to be looking at a neutron like this, and this is going to be because of the next section where we talk about nuclear chemistry. For now, just cuz. Alright, so as we go through symbols of elements, when we look at the symbols of elements, we have a symbol, we deal with atomic number, and we deal with mass number. Now, all three of these things together, when you look at the symbol, the atomic number, and the mass number, we're looking at what's known as a nuclide symbol. Okay? Okay, a nuclide, basically you have the symbol, you have the mass number over the atomic number. And this is a nuclide. This is how we differentiate between isotopes. So isotopes, notice that we have the same symbol, we have the same atomic number, okay? What differs is the number of the mass number, which means the difference in the mass is because of differences in neutrons. Okay, mass number by definition was, okay, when we look at mass number from the previous slide, remember mass number was the number of protons plus the number of neutrons. So if my proton number is the same, that means differences in mass have to be due to the neutrons. So I have 6 protons, 6 plus what's going to give me a 14 mass? Well, I have 8 neutrons. Okay, you go all the way to carbon 11, I have 5 neutrons. You get the idea. Other examples, uranium-234, uranium-235, uranium-238. Again, because it's uranium, you know that the atomic number is 92. If you know the atomic number, you can determine the number of neutrons. So, practice. When you look here, notice you're given mass number, atomic number. Here you're given the nuclide symbol. Here you're given the symbol, number of nucleons, number of protons, and number of neutrons. So, with any aspect of this set of information, you can fill in all the blanks. Notice our rules. So, we have rules. We know atomic number equals the number of protons. Number of protons defines the element. Okay, that means we're talking the symbol. Okay, and we know number of nucleons equals protons and neutrons, and that's the mass number. Okay, so we get a new term. Nucleons, by definition, we're dealing with particles in the nucleus, hence the nucleons. And we know protons and neutrons are in the nucleus, and that determines the mass. So there you go. Now, when you go through, again, since we looked at the rules, atomic number, number of protons. So if I have 26, I have 26. Now, if I know mass number, okay, I know the number of nucleons. So if there's 56 mass number, that means my nucleons are 56. And if I know my number of mass, my mass number, and get that circled, and I know my number of protons, okay, remember, protons and neutrons equals mass, so that means I subtract, so I should have 30 neutrons. And now we fill in the nuclide. Remember, nuclide symbol, we are looking at a mass number over atomic number next to the symbol. Well, here's my mass number, here's my atomic number, so you just have to look up the symbol. Well, what symbol goes with 26? Fe, so you should have 56 over 26 Fe. Pause this screencast now and fill in this next line. Alright, so when you fill in the next line, because this was known, okay, we knew 17, we know 17 and 17. We knew 38, so we knew 38 and 38. And since we know neutrons is the result of protons and neutrons equals the mass number, again I subtract, so now I get 21. Pause, go to the next slide. Alright, so now when we go to this next slide, you can see that, okay, you were given, let's go back, you were given the nucleons and the nuclide symbol. Okay, well, if I know the nucleons, I know the mass number. If I know the symbol, I know the protons and the atomic number. Now notice here we have the exact same element with a different mass. The same element, notice these are the same, so that means what has to be different? are the neutrons. Sure enough, we have a mass that's 2 less, we have 2 less neutrons. You get the idea. So now, pause it, solve the next line. Alright, so you should have everything filled in, same thing as before. We know we have the mass number, we have the atomic number, there's our symbol as a result. We know the number of protons and the number of neutrons gives me my mass number, which gives me my number of nucleons, etc., etc. Alright, now the reason we care about this, or how we use this information, especially specifically what we're going to be using are the nuclides, is in determining atomic mass. Now when we determine atomic mass, the reason we do this, we have to use an average, and we'll actually talk about the reason we have to use an average in the next section when we talk about moles. For now, just cuz. Alright, so we're going to use an average because there's large amounts. Now when we use these large amounts, what you want to recognize is what we're looking at when we use an average. It's a calculation. It's weighted, okay, based on relative abundances. So those are our key terms. Now when we talk weighted, keep in mind that means what we're doing, it's sort of just like calculating a grade. Oops, go to pen. When you calculate a grade, for example in this class, 25% of your grade comes from your online homework. Okay, 35% comes from your labs. So that means whatever your score is here, that score is 35% of your total grade. You get the idea. That's all weighted is. Now, relative abundance means percent. Okay, you remember that. Basic math, previous classes, etc. So we're dealing with percentages. So when you go to solve these problems, when we're actually doing the calculations, okay, notice what it says to do in terms of solving the problem. In other words, what we're going to do is we calculate it by multiplying the atomic mass of each isotope, okay, by the relative abundance. Notice also when we are dealing with relative abundance, okay, it's when it's in decimal form. You remember basic things for math. Do we ever multiply by a percentage? No. So literally what you do, you take, okay, there's our percentage put in decimal form. Okay, here's our mass plugged in. Okay, and so what you see is you see that we take our mass times our abundance in decimal form. There are two, notice you're given two sets of ions. Okay, we have 63 and we have 65, and what do you know? We see 63 and we see 65. You just solve the problem, plug it in and solve. Now here, the difference you need to notice is right here. Notice that the mass isn't quite exactly 63. There's a lot of reasons for this. Mass defect, relative mass, AMU is a result of a relative mass related to carbon-12, which we'll be talking about. The point I want to make is notice now if you're given the actual mass in AMUs, that's what you're plugging into the problem. The percentage hasn't changed. The use of the percentage times the mass hasn't changed. It's just the number that we're using. You're not going to use the 63 if you've actually been given the mass. That's the point. Alright, so now we've talked about how atoms differ in terms of neutrons. Now we're going to talk about how they differ in terms of electrons. So you gain or lose electrons. So if we gain or lose electrons, that's what makes something an ion. And you remember this from previous classes. I mean, this is nothing new. Notice that we are kind of using our staircase. We know everything to the left is generally positive. Most things to the right are generally negative. And that what we're looking at when we look at a cation or an anion, we're comparing, okay, because in a neutral atom, the number of protons equals the number of electrons. Okay, what you want to notice here, charges. Alright, so if I have these charges, and when they're equal, I get something neutral, that means the only way to produce a charged particle of a cation or an anion is to have some kind of inequality. I either have more protons than electrons, or I have more electrons than protons. Alright, if I have more electrons than protons, the particle is negative. If I have more protons than electrons, the particle is positive. Now, we don't gain or lose protons. It's gain or loss of electrons. So that means to produce a positive particle, electrons were lost. To have more electrons than protons, proton number never changes, I gain electrons. Okay, to make the point. For example, look at fluorine there. Okay, fluorine here, fluorine is -1. It's still fluorine. Okay, if I have fluorine and I have fluorine charged, technically this is called fluoride, but we'll get there. If I have fluorine versus fluoride, it's still fluorine. It still has 9 protons. No matter what, it has 9 protons, whether it's neutral or charged. So if the protons don't change, the electrons had to. Okay, quick review, reminder, you got to make sure you keep that straight. So now you're basically going to count, just fill in the chart. Quick reminder, protons, atomic number, and now we're not dealing with a nuclide, I just want you to fill in the symbol. So again, we know the number of protons defines the atomic number defines the symbol. So I know this relationship. So I can fill it in, 26, 26, Fe. We just had that in the previous slide, didn't we? Or previous few slides. All right, so now we have 26, 26, Fe. So we're going to go through and fill it in. All right, so when you filled it in now, you also know mass number minus the number of protons is going to be the neutrons, so you know it's 30. And notice that the number of electrons is different from the number of protons, so I'm going to fill in a symbol. Now, when we do symbols for ions, it always goes on the right-hand side. It's going to go over here. So what you should notice, I have more protons than electrons, so the charge has to be positive. How many more? 3, so it should be 3 plus. Now, using this information, fill in. All right, so you should have had 18 here, 17 here, 17 here, and 36. Again, usually this is where most people make the mistake here, is recognizing one negative. That means I should have one more electron, so it should be 18, not 16. Pause, solve the next one. All right, so when you go to the next one, again, you're going in 86, 222, 86, 86. Okay, right here. Remember, we assume atoms are neutral, so that's how you could find the electrons for this one. Okay, so now there's going to be a series of pictures of problems. You need to solve these, so here's the first one. Pause it and solve it. All right, your answer when you work this out, oxygen 16, should be number 1. Pause it. Okay, so when you go through here, you're going to figure out bromine was 35. Protons should equal electrons. You get the neutrons, so that means here the answer is number 1 again. Okay, you should pause it here. I'm not going to give you the answers. We'll work these out in class if you need to. Again, recognize it should be, okay, your decimal percentage, because we take the relative abundance in decimal form, times the mass plus however many isotopes you're given. Notice you're given only 2 isotopes here. When you go to the next problem, you're given 1, 2, 3, and notice the difference. Here you're just given carbon 12 and 13. Here you're actually given masses, so make sure you use those both. All right, the last one. Pause it and solve it. Okay, when you're going through here, a couple of things you want to recognize. Okay, you're given, you know it has 2 isotopes. Okay, we know that one has this mass with this percentage. We know the other one has this mass, but we're not given the percentage. Well, guys, there's only 2. Have to equal 100%. So if I know one percentage, guess what? By definition, I know the other percentage. So solve it. You'll notice the answer listed at the bottom. So obviously, what should you get as an answer up here? Okay, so should have been 6. Make sure that's the answer you get. If you don't, make sure you ask some questions tomorrow.